The differences between a cough of an asymptomatic patient and a healthy individual are not decipherable to the human ear, but it turns out that they can be picked up by artificial intelligence. For example, here is a cough of a healthy individual. And now here is a cough of an asymptomatic person with COVID-19. To make things even more challenging, listen to a person who has symptoms and is COVID-19 positive. It's very hard, frankly almost impossible, for a person to distinguish these three coughs, even after you've listened to them multiple times. But a team of MIT researchers report they have developed an AI model that can distinguish asymptomatic people with COVID-19 from healthy individuals without the disease through forced cough recordings.
Hi everybody, this is Ahmed Mahfouz. Thank you for listening to this portion from the MIT podcast. This MIT article, when it came out along with this podcast, what really motivated and triggered me to start working on this project. Imagine you can get an indication just using your cough sound if you're healthy or have contracted something like COVID using an app on your phone. When I first came across this article, I started looking for the dataset the scientists in MIT used, but these datasets are not publicly accessible. I found some datasets on Kaggle between a small and medium size ones. The largest one were around 166 recordings. I kept looking until I found a GitHub repo for a community called Verify. They don't have the dataset available on their repo, but you need to submit a form to get access and join the community. I submitted a form and I received a response that unfortunately the community is inactive, but they send me all the resources that include a link to the dataset. Apparently, the dataset is available online for everyone from the Embedded Systems Lab, and it's called COUGHVID. COUGHVID dataset, to give you an overview, it has around 20,000 plus cough recordings. Also, they have built a cough detection model to score each recording if it contains a cough sound or not. They also run it through some expert and they were able to annotate 2,000 plus of them. Since we're dealing with audio recordings, so how we can extract features so we can use it for machine learning and data mining. Using digital signal processing, there are some features that can help us characterize and differentiate between sounds. Some of the features are the spectrogram, zero crossing rate, spectral centroid, spectral roll-off, and finally, the mil frequency capistrel coefficients. This is the process I have followed, and I started with the compressed audio files from the dataset, the WebM and the OGG audio files, following the same method COUGHVID did, and I decompressed them to a WAV raw audio file using FFmpeg, and using the low-pass filter COUGHVID open sourced. Then after that, I started using two libraries, the librosa to extract the audio features I just talked about, and matplotlib to produce images for the recording's spectrogram. After I had the data ready, I started to train my first model, but the problem and the hurdle I started facing that the dataset is very imbalanced. Almost half of them only has a status, which is the label column. It's 1,000-something of them are healthy and 1,800 are symptomatic, which I already discarded because I'm only interested in the healthy and COVID-19 ones, which is the COVID-19 ones are only 1,010. But after trying different approaches between upsampling, downsampling, filtering the data using different columns and different criteria, but they were all unsuccessful. Finally, when I decided to use the cough detected column, which has a value between 0 and 1, which represents the accuracy of having a cough sound in the recording, and I started using it to downsample the healthy recordings, and I couldn't afford to lose anything from the COVID-19 ones, so I just tuned the cough detected label for the healthy recording, so to anything above 0.993, and that almost gave me the same number of recordings for each class. Then I started building my neural network deep learning model using Keras and TensorFlow, and after so many iterations trying different configurations for the layers and different activation functions, I finally was able to build a model using a sigmoid activation function, and that produced good accuracy around 81% and a good F1 score for both classes. After that, I have built another model using the same deep learning model, but adding to it MobileNet version 2 so I can use the spectrogram images for the recordings that I already extracted. And After some iterations, that didn't really produce similar results to using the audio features. And as you can see, the accuracy and the F1 score really were very poor compared to the audio features.